Good evening. My name is Ruthwick Nama, and today I'm going to take you on the journey of the smallest planet in our solar system, Mercury. I'll first introduce Mercury and explain what it is, and then I'll move on to surface features, atmosphere and magnetic field, internal structure, rotation and revolution, temperature differences, polar ice caps, missions to Mercury, explain why Mercury matters, and finish off with a conclusion and references. Let's start off by taking a closer look at Mercury. Mercury is the smallest planet in our solar system and the one closest to the Sun. It orbits the Sun at an incredible speed, so fast that a full year on Mercury lasts just 88 Earth days. Its surface is heavily cratered and rocky, shaped by countless of collisions over billions of years. These impacts have left Mercury looking a lot like our Moon. Also, Mercury doesn't have a true atmosphere. Instead, it has a very thin layer called an exosphere. Now that we have a general introduction, let's dive deeper into Mercury's surface features. But before that, I have a quick fun fact for you. Did you know that in 2012, Mercury had a crater named after renowned children's book author and cartoonist Dr. Seuss? Now, back to Mercury's surface features. Mercury's surface is rocky and heavily cratered, much like the Moon. This battered appearance is due to billions of years of impacts from meteoroids and comets. But among its most striking features are its enormous cliffs called scarps. These giant cliffs were formed as the planet gradually cooled and contracted, causing the crust to crack and thrust upward. Some scarps stretch for hundreds of kilometers and rise up to 2 kilometers high. Another prominent feature is the Chloris basin, one of the largest impact basins in the solar system. This colossal crater spans about 1,550 kilometers and was created by a massive asteroid impact. The formation of Chloris not only shaped the landscape around it, but also created seismic waves strong enough to disrupt the terrain on the opposite side of the planet. But Mercury isn't just a dry rock in space. Let's take a look at what kind of atmosphere and magnetic properties it has. Mercury has no dense, breathable atmosphere like Earth. Instead, it has a very thin layer called an exosphere, which isn't even a real layer. An exosphere is made up of atoms that are blown off Mercury's surface by the solar wind and micrometeorite impacts. They consist of oxygen, sodium, hydrogen, helium, and potassium, which float freely above the surface but are too light to provide any weather or radiation protection. Although it is small and slow to turn, Mercury possesses an unexpected magnetic field. This is only 1% as strong as Earth, but it still exists, especially for such a small planet. Scientists take the weak but real magnetic field as evidence of a partially molten iron core. The magnetic field can deflect some of the solar wind, creating magnetic disturbances near the planet. Now, let's go beneath the surface and explore what lies inside the planet, its internal structure. Mercury's interior is dominated by a massive iron core, making about 85% of its radius. This gives Mercury the second highest density in the solar system after Earth. The molten iron inside is thought to help generate its weak magnetic field. The core has two parts, a solid inner core and a molten outer core. The liquid outer core likely drives the magnetic field through a weak dynamo effect. The solid inner core offers clues about Mercury's early formation and thermal history. Outside the core, though, is a thin mantle of silicate rock. Unlike Earth's active mantle, Mercury is geologically very quiet and may have been mostly inactive for billions of years. Its thinness allowed the planet to cool and contract very quickly. Mercury's crust is only about 35 kilometers thick and is made of silicate material and is covered in impact scars. As the planet cooled, the crust cracked and formed the giant scarps seen today. Let's now look at how Mercury moves through space. Mercury rotates very slowly, completing one full spin on its axis every 59 Earth days. Its orbit around the Sun is much faster, though, taking just 88 Earth days to complete a year. This unique relationship results in what astronomers call a 2 by 3 resonance, meaning Mercury rotates 3 times for every 2 orbits around the Sun. As a result of this resonance, a single day on Mercury actually lasts about 176 Earth days. This combination of slow rotation and fast orbit plays a major role in shaping the planet's environment, especially its extreme temperature differences between the day and the night. And speaking of environment, Mercury has some of the most extreme temperatures in the solar system, so let's take a look. During the daytime, temperatures on Mercury can soar as high as 430 degrees Celsius, making it one of the hottest places in our solar system. However, once the sun sets, the temperature plummets down to an incredible negative 180 degrees Celsius. This extreme difference of over 600 degrees Celsius between the day and the night is caused by two main factors: Mercury's lack of a substantial atmosphere and its very slow rotation. The planet's thin exosphere cannot trap heat the way Earth's atmosphere does, so any heat absorbed by the sun during the day is quickly lost once the sun goes down. Additionally, because Mercury rotates so slowly, any given spot on its surface experiences prolonged exposure to sunlight, followed by extended periods of darkness. This slow rotation, combined with the inability to retain heat, results in these dramatic temperature extremes. But even in such a hot and cold wind, scientists have discovered something unexpected: ice. Ice has been discovered in permanently shadowed craters near Mercury's north and south poles. These areas never receive sunlight due to the planet's almost zero axial tilt, only about 0.03 degrees. This means that some crater floors remain in perpetual darkness, allowing temperatures to stay low enough to preserve ice. Scientists believe the ice was likely delivered by comets or meteoroids that crashed into the planet over millions of years. Once in the shadowed regions, the ice remains stable despite the planet's proximity to the sun. Discovery of ice in such an unlikely place helps scientists understand more about the distribution of water in the solar system and how volatile materials can survive even on planets as seemingly inhospitable as Mercury. So now, let's shift over to how we learned all about this through the space missions that we had. Our understanding of Mercury comes from several important space missions. Mariner 10, launched in the 1970s, was the first spacecraft to visit Mercury. It conducted 3 flybys and provided humanity with its first close-up images of the planet's cratered surface, revealing many of its geological features for the first time. Then, NASA's Messenger mission orbited the Mercury from 2011 to 2015 and provided lots of detailed information. It mapped the entire surface, measured the magnetic field, studied the composition of the crust, and confirmed the presence of ice in permanently shadowed craters at the poles. Currently, Bepi Colombo, a collaborative mission between the European Space Agency and the Japan Aerospace Exploration Agency, is on its way to Mercury. It was launched in 2018 and is expected to arrive in 2026. Once it enters the orbit, Bepi Colombo will build on Messenger's data and provides even more precise measurements of Mercury's magnetic field, exosphere, and surface composition. As astronaut Anne McClain once said, "With so much conflict in this world, space exploration can be a beacon of hope." This quote reminds us that in studying planets like Mercury, we're not just learning about our solar system, but we're shaping a more connected and inspired future. So, studying Mercury offers vital clues about how planets form and evolve. Its unique core and magnetic field challenge our models and helps us learn more about Earth's own interior and magnetic behavior. So in order to wrap up, I'll summarize what we've discovered about Mercury. In conclusion, Mercury might be the smallest planet, but is full of lots of scientific questions. Whether it's about the giant scarps it has, or the surprising presence of water ice in permanently shadowed polar craters, Mercury is constantly facing challenges, what we think we know about rocky worlds. Despite it being so close to the sun, Mercury still proves to be an active world with a rich past. So while Mercury might be small, the lessons it holds could have a massive impact on our knowledge of the universe. Here's my reference page cited in APA, which has all the credible sources I used to gather my information on Mercury. Thank you and have a great day.